Let me know once you are ready.
So the recording has been started. So for anyone who's doesn't want their name or voice or questions to be answered, now might be a good time for you to leave and then catch it on YouTube when we get it posted. But the recording has started.
All right, thanks. Hey everyone, good morning, good afternoon, good evening, depending upon whichever time zone you are in. Thanks for joining us live today for this session. If you are watching it on YouTube, I welcome you as well. I would like to thank Jason, Veronica, and others who run this user group for giving me an opportunity to speak. Today I'm going to talk about Azure Networking. This is going to be a level 100 session where I will touch upon different Azure networking services. This will not be a deep dive session into any particular networking service, but I can assure you that it will be helpful to you if you are planning to learn about Azure networking. It would also be helpful to people who are preparing for their Azure role-based certifications. So just a disclaimer, I'm not a networking expert. I come from application development background, but I do work extensively on Azure, making it extremely important for me to know the networking aspects of the cloud. If you are someone like me who use Azure at your day-to-day job, or if you are willing to learn Azure, I hope I'm going to make it easy for you today. I'm not saying that you will become an expert in Azure networking after my presentation, but I can assure you that I'll share enough information with you that will help you get started and keep going. With that, a few guidelines. If you have got a question or doubt in between the presentation, please post it on the chat window. I will get back to those as and when I get an opportunity or at the end of the presentation. Please stay on the mute to avoid any distractions. And if you would like to talk to me, I would be more than happy to hang out in this meeting after the presentation. With that, let me introduce myself. My name is Vaibhav Gujral. I have over 14 years of experience working on enterprise class applications. I'm Microsoft certified Azure solutions architect expert, and I also hold few other certifications. I'm currently working for Kivit as a cloud architect here in Omaha, Nebraska. I'm also an organizer at Omaha Azure User Group, which has over 750 community members in Meetup. And as an organizer, I do organize user group meetings and manage user groups website, social media presence, and the Meetup page as well. Feel free to join the community if you're interested. As Jason was mentioning, we have also gone virtual, so everyone is welcome in our meetings. I'm a regular speaker at user groups like this one, speaking on Azure related topics, and I also blog on webofgujral.com. Recently, my blog has been listed among top 50 Microsoft Azure blogs, websites, and influencers in 2020. I have also been recognized with Azure Heroes Community Hero and Content Hero badges based on my contributions in the Azure Tech community. You can follow me on my Twitter account, or you can connect me with me over LinkedIn as well. With further ado, let's jump onto agenda and see what we are going to talk today. We'll be starting with basics. We'll talk about Azure regions and data centers. Then we'll talk about virtual networks, VPN gateways, network security groups, routing. We'll touch upon different load balancing options towards the end, and I'll conclude the session with network monitoring. Uh, I intend to cover a couple of quick demos as well. Just a disclaimer, most of the figures that I have used in this presentation are taken from Microsoft documentation. With that, let's get started. So when I speak to many colleagues and friends of mine, one of the observations that has been that I have seen is that they don't really understand what an Azure region is. And the confusion that I have seen is they often relate region and a data center as the same concept, which is partially incorrect. Everything in Azure do starts with a data center, which is analogous to your on-prem data center if you have one. And in Azure as well, a data center is nothing but a group of buildings which is used to host physical infrastructure, including racks, switches, servers, and so on. Whereas whereas a region in Azure is a collection of those data centers which are deployed within proximity with a network latency under 2 milliseconds. Another thing to note here is that Microsoft then groups these regions under geographies, which is to comply with data residency and other laws, other compliance laws. Geographies are fault tolerant to withstand complete region failure through their connection to Microsoft's bandwidth. And moreover, geographies are formed with a combination of multiple regions, making them fault tolerant. Last thing that I want to touch upon is availability zones, which are physically separate locations within an Azure region. An availability zone is made up of one or more data centers, which are equipped with independent power, cooling, and networking. What you see here is different geographies with their different regions under them. There are six geographies altogether: Americas, Europe, Asia Pacific, Middle East, and Africa, Azure government, and China. And under each of those geographies, there are multiple regions which make them fault tolerant, as I was mentioning earlier. If we will have a look in Americas, we have in total 11 regions ranging from East US, Central US, North Central US, and so on. In Europe, there are 15, and in Asia Pacific, there are 13 regions. This gives a slightly better view of different regions in different geographies in Azure. The blue circles that you are seeing there represents a region in each of the geography that is available for consumption where you can deploy your Azure services. Then the ones which are with dotted circle, like the one it's in Spain or Mexico Central, they are the ones which are announced and are not yet available. They will be available in the recent future. Then there are few which have those diamonds embedded in those blue circles. Those indicates the regions which have availability zones available, which you can select when configuring your resources in those regions. Now, it's important to note here that when you choose a region to deploy your resources to, there are few considerations to keep in mind. Certainly for data compliance and regulatory reasons, you might have to choose a particular region. For example, GPDR, we might have to put the data in Europe, but you should also keep in mind that not all the services are available in all the regions. So I have mentioned a link there, which points to the global infrastructure page for Azure. Go and check it out. It gives you the latest list of available regions and what products are available under each of those regions. Or rather, let me see if I have that open. So this is the page that I was mentioning about, which details all the different regions. You can go here and look for different Azure geographies and see which regions fall under each of those geographies. You can explore each region. You can find out which products are available in which region. Let's say if I want to find out the stuff which is running in United States, let's say if I want to see virtual machines, it gives a clear view of which product is available in which region and which is going to be available in future. Moving on my presentation. Here's a snapshot of how many services Azure offers today. On the lower bottom is the Azure Data Center infrastructure, which is the physical infrastructure owned and managed by Microsoft. On top of that, you have infrastructure services categorized primarily into three categories: compute, storage, and networking. On top of that, you have all the different platform services, which are customized to suit different needs like web services, IoT, AI, data services, and so on. On the left side, you see the suite of management services, which you can use to manage your Azure environments. And to your right, you can see the Azure services like Azure Monitor, Azure Blueprints, Azure Policy, which you can use for governance. You can also see Azure Cost Management, which is a service used to manage your Azure costs. I'm sorry, that's on the left side. To the right side is your security services. And today we are going to focus on the networking services. We'll look into some of the services like virtual network, VPN gateway, ExpressRoute, load balancer, and so on. So let's start with the very basic building block in an Azure network. It is called as a virtual network, which is a fundamental building block for a private network in Azure environment. Being a private network, it brings isolation on top of other Azure features like scalability, availability, and so on. You can place your Azure resources inside a virtual network to securely communicate with each other or with internet or with your on-prem resources. It's analogous to a traditional network that you would have managed and operated in your on-prem data centers. So when you create a virtual network, you need to define a RFC 1918 IP address space. If you're not aware of RFC 1918 specification, I would strongly encourage you to read about it. What it does is basically defines the best practices for your private network. It states that the different IP addresses within your enterprise can be categorized into 3 different categories, starting with the hosts that do not require access to the host outside their enterprise. In such environments, the IP ranges are not ambiguous within the enterprise, or in other words, they are unique within the enterprise, but they might overlap outside the enterprise. The second category that RFC 1980 classifies is the hosts which need limited access to the services outside your environment, right? Like email, FTP, RDP, and so on. And like the first category here, the IP address ranges are also non-ambiguous or unique within the enterprise, but they might overlap with the entities outside the enterprise. And lastly, the third category that RFC 1918 defines is the category of hosts which have network layer access to the resources outside the enterprise, meaning they just don't need to have IP addresses unique within their enterprise, but they also need to have IP addresses unique globally. So the RFC 1918 standard allows 3 different IP ranges that can be used within any private network. I have listed them on my slides. They are 10.0.0.0 to 10.255.255.255, 172.16.0.0 to 172.31.255.255, and the last one is 192.168.0.0 to 192.168.255.255. When creating a virtual network, you have to define the IP address ranges in CIDR notation, which is basically based on the idea of subnet masks. It requires you to provide the IP ranges in 2 parts, a network identifying prefix, followed by a host identifier within that network. The highest prefix that you can use is /32, and the number of IP addresses double with every reducing prefix. Now, the example that I have taken here is 192.168.100.14/24, which has 24 as a prefix. It denotes my IP address range can have 256 IP addresses, ranging from 192.168.100.0 to 100.255. Now note that at max, a virtual network in Azure can only have up to 65,536 private IP range addresses, which translates into /16 prefix. So you cannot have a prefix lower than /16 for IP address ranges for your virtual network in Azure. You can further segment your virtual networks into something known as subnets. If you have a networking background, you will understand what subnet is. You can have up to 3,000 subnets within a virtual network. The traffic is enabled by default between the different subnets within a single virtual network. It is important to understand that a virtual network is scoped to a single region in subscription. What you are seeing in the figure here is how it is laid out when you create a subscription within an Azure region and a subscription. You can have a virtual network with one or more subnets in it. And you can also have resources assigned to each of these subnets then. Why scope is important here is because of two things. First of all, you cannot have a virtual network with the same name in the same scope. So, and secondly, it is important to plan your virtual networks across different regions and subscriptions, because if you intend to connect two different virtual networks, they cannot have overlapping IP address ranges. In other words, you cannot connect two virtual networks with overlapping IP address ranges due to the conflicts that might happen between the IP addresses. All resources in a virtual network can communicate outbound to the internet by default. So, and you can use something like network security group to restrict the network traffic at a subnet level. We are going to touch upon network security groups in the later slides. If you need to enable inbound communication to your resources from internet, you can do so by assigning a public IP address or a public load balancer. You can also use a public IP or public load balancer to manage your outbound connections as well. A few best practices when you are creating your virtual networks. To start with, as I was saying, avoid non-overlapping address spaces when you are creating your multiple virtual networks, so that if you are pairing those two virtual networks with each other in the future, then you need to have non-overlapping address spaces. Ensure that your subnets don't cover the entire address space of the virtual network, meaning for the example that I have taken in my last slide, I have taken /24 prefix for my virtual network. So if I'm defining subnets, I should probably take /26 or /27 as the address range for my subnets, and avoid reserving the complete address space for the virtual network within a single subnet. And that being said, I don't really mean that we should have many small subnets. It depends upon the individual organization's requirements. And it's better to have fewer large virtual networks at enterprise level than having multiple small virtual networks. Because if you have multiple small virtual networks, it gets really tricky to manage the underlying subnets. If you really have to break down your IP address ranges, you can create few large virtual networks and have smaller subnets within them. Lastly, do ensure to secure your virtual networks with network security groups. I have posted a link down there where you can head out to check out the guidance on how to better plan your virtual networks when you are designing them. Let's quickly go to the Azure portal and see what we can do in. So let me show you first how we can create a virtual network in Azure portal. So I'm already in my Azure portal where I have logged into with my live ID, to which I already have a subscription assigned. I'm going to click on create a resource and gonna search about virtual network. Click create. It's going to ask the subscription and the resource group, which defines the scope where your virtual network is going to exist. I'm going to use an existing resource group which I have created, but you can create a new one if that's a requirement. I'm going to rename it as VNet4 because for the purpose of demo I have already created 3 more virtual networks. I'm gonna keep that in the same in the Central US region. I can define one or multiple IP address ranges here. I will go with the default one. It comes with /16 prefix, meaning my virtual network will have 65,536 IP addresses that I can use within my virtual network and distribute across the different resources. I can likewise add IPv6 address spaces. And this is where we can add for more subnets. So you can see here my virtual network address space range is /16, whereas my subnet has prefix of /24. I can go ahead and add one more subnet like that and keep on breaking my IP address range within a virtual network into multiple subnets. I'll just go with the default one for now. We'll talk about all these features in the later slides, and I'll go ahead and click on create. So it's gonna take a minute or so. I already have few virtual networks created. So this is how once the virtual network is created, and the other one which I have set it up is also created. So as you see, this is the address space that I have specified. This is my subscription. This is my resource group where it sits, and this is the address space. I can go ahead and add additional address space if I'm running out of IP address ranges in future. Here are my subnets. If I want to add more subnets, I can go ahead and add a subnet here. Moving on, we have just seen what a virtual network is, how we can create it. Let's talk about a VPN gateway. VPN gateway is a specific type of virtual network gateway that is used to send encrypted traffic between an Azure virtual network and an on-prem location over the public internet. You can also use a VPN gateway to send encrypted traffic between virtual networks within Azure. Each virtual network can have only one VPN gateway. So hence, you can create multiple connections to the same VPN gateway. So when you create multiple connections to the same VPN gateway, all VPN tunnels share the same gateway bandwidth. Please take a note of that. There are two types of VPN gateways that you can use, VPN and ExpressRoute. Note that even though a VNet can have just one VPN gateway of type VPN, it can still have an additional VPN gateway of type ExpressRoute. When you create a VPN gateway and attach it to a virtual network, it does creates an exclusive subnet called as a gateway subnet in the virtual network that is used to host the resources that are required by the gateway. That is what you see here. Once you create a VNet VPN gateway and attach it to the virtual network 4, it will create a gateway subnet here automatically, or you can go ahead and create it explicitly on your own. A VPN gateway supports different connectivity scenarios. Starting with, as I was mentioning in my last slide, we can use it to connect multiple virtual networks within your Azure environment. Those virtual networks can be in same or different regions, same or different subscriptions, or they could have used either ARM or the classic deployment model. If you're not aware of the different deployment model, as I said, there are two, classic and ARM. ARM stands for Azure Resource Manager, which is the current standard, and all the old resources before ARM were called classic. Earlier it used to call as ASM or Azure Service Management. You cannot create those classic resources anymore, as far as I am aware. But if you have any existing classic virtual networks, you can still connect them with each other or with the ARM-based virtual networks using a VPN gateway. Now, when you create a virtual network to virtual network gateway, it creates an IPsec IKE VPN tunnel between two different VNets, as depicted in that figure. VPN gateway sits in front of each VNet, and VPN gateway talks to each other to enable communication between those two VNets. It's pretty straightforward. And as I was saying, since there is only a single tunnel, the complete bandwidth is dedicated to that particular tunnel. The other option that's available under a VPN gateway is for site-to-site connectivity. It provides a connection over IPsec IKE VPN tunnel. Site-to-site connections can be used for cross-premises and hybrid configurations where you want to connect your sites with your Azure environment. It requires a VPN device to be located on-prem that has a public IP address assigned to it. You can also extend site-to-site into multi-site. connection where you can connect your multiple sites like your branch offices or department offices with the Azure Virtual Networks. You need to note here that you need to have a VPN device located at each of these branch offices or department offices and each location. And each of the tunnels that you establish for with each of these offices, each one of them will share the available bandwidth at the gateway. Similar to a site-to-site VPN gateway, we can also have point-to-site connectivity between Azure Virtual Network and remote client computers. And similar to site-to-site, the bandwidth at the VPN gateway is shared across all the tunnels that are created. As I was mentioning earlier, that one way to connect virtual network is certainly VPN gateway, but they are not the best way to do it because their primary use case is to connect, to have cross connectivity between on-prem to Azure resources. The recommended way to connect multiple virtual networks with each other is through virtual network peering, where you can peer one virtual network with another. The outcome is that the IP address ranges of the virtual network peers appear as a single virtual network IP address range, and the resources between both the virtual networks can communicate with each other with minimal latency, as they would have done with the other resources within the same virtual network. Depending upon the location of the virtual network or the region in which the virtual network peers are in, the peering falls under one or the two categories. If both of your virtual networks are in same region, it is counted as virtual network peering, or as I call it as intra-region peering. If the virtual networks are in different regions, it is counted as global network peering. You need to be aware of the cost implications for both types of peerings. For virtual network peering, you pay for inbound and outbound data transfer at both the virtual networks, and comparatively the cost for global peering is more than the virtual network peering since it crosses different regions. Another thing to note here is that VNet peerings are not transitive. What you see in the diagram here is how you can connect your different virtual networks with each other. Here virtual network A is paired with virtual network B, which is in turn is paired with virtual network C. Here virtual network B can communicate with both virtual networks A and C, but virtual network A and C can communicate only with B and not between each other. Now both the peerings do support gateway transit, meaning if one of the peered virtual networks have a VPN gateway configured, the peered virtual network don't need to have a gateway on their own, and they can use the remote gateway. What you are seeing here is a network topology which is very commonly implemented across enterprises. You can refer to the link listed below for more details on this. It is known as hub and spoke topology. In a nutshell, you can create a hub virtual network and peer multiple spoke virtual networks to the hub. The hub can be either connected to a VPN gateway or something known as ExpressRoute for on-prem connectivity. We'll talk about ExpressRoute in the next slide. Generally, hub virtual network is the central point of connectivity between your Azure environment and your on-prem resources. It is used for deploying management resources and shared resources like firewalls, which can be shared with the different resources sitting in your spoke virtual networks. In turn, these spokes have the resources that are intended for isolated workloads, which can be managed separately. Using hub and spoke offers some benefits, like it does improves management. It might result in cost savings if implemented correctly. It helps getting over subscription limits that exist for virtual network, as the hub and spoke virtual networks can sit in different subscriptions. And most importantly, what you can achieve here is the separation of concerns. So your central IT team can manage the hub virtual network, which has all the shared resources, and your development teams can have their own spoke virtual networks where they can run their own isolated workloads. So before we jump onto ExpressRoutes, let's do a demo on virtual networks. So I have already created a resource group, as I was mentioning in before, where I have created 3 different virtual networks, virtual network 1, 2, and 3. Under each of those virtual networks, I have created a virtual machines. Virtual machine 1 sits in virtual network 1, virtual machine 2 sits in virtual network 2, and virtual machine 3 sits in virtual network 3. And I have already configured peering between virtual network 1, 2, and 3. If you will go here and look at the peerings, you can see I have peering established between VNet 1 to VNet 2, which is enabled. And I have not enabled gateway transit since I don't have a VPN gateway configured. Likewise, if I will go and see for VNet 3, I have a peering between VNet 2 and 3. I'll go back to the virtual network 2, which has peerings with both 1 and 3. Now let's switch to the virtual machines. This is my virtual machine 1, which has an IP address 10.0.0.4. Let's go to the virtual network C1 and see where is that virtual machine. You can see it sits, the IP address that I've shown sits within that IP address space. Here is my device that is attached to that virtual network, which is the network interface card for my virtual machine. And it has the same IP address that I was showing you here. Likewise, if I go to my other machine, it has 10.1.0.4. It sits in virtual network 2. I can show it to you quickly here. This is the 10.1.0.4. And this is my virtual machine 3, which sits in 10.2.0.4, which is my virtual network 3. Here you have 10.2.0.4. So now what I'm going to do is, as I was saying, VNet peering is not transitive, meaning since virtual network 2 is connected to 1 and 3, the machine which runs in that virtual network can be able to reach out to machines in both the other networks, but the machines in virtual network 1 or virtual network 3 can only talk to machines sitting in virtual network 2. Meaning VNet, my virtual machine 2 can talk to both virtual machine 1 and 3, but virtual machine 1 and 3 can only speak to virtual machine 2. So let's go ahead and ping, let's say 10.1.0.4. This is my virtual machine 2. I'm pinging it from my VM1, so I can reach to virtual machine 2 from virtual machine 1. Let me go ahead and ping virtual machine 3, and as expected, since VNet peerings are not transitive, I cannot reach out to. Likewise, I can try that out in my virtual machine 3.0.0.4. This is my virtual machine 1. It cannot reach out to it because it's not peered with that virtual network. I will go ahead and ping. And since my virtual network 2 is paired with virtual network 3, my virtual machine 3 can reach out to virtual machine 2. Now let's come to the virtual machine 2, which can actually hit to the other 2 machines. Let's try pinging 10.10.0.4. I can get a response from back. Let's hit I can get the response back from both the virtual machines. Moving on, let's talk about ExpressRoutes. ExpressRoutes provides layer 3 connectivity between your on-prem network and the Microsoft cloud over a private connection, which is facilitated by a connectivity provider. With ExpressRoute, you can establish connections to Microsoft cloud services as well, like Office 365, Connectivity can be any-to-any or a point-to-point Ethernet network or a virtual cross connection through a connectivity provider. The point to be noted here is that ExpressRoute connections provide private connectivity and the traffic does not go over the public internet. This allows ExpressRoute connections to offer more reliability, faster speeds, and consistent latencies. Microsoft uses Border Gateway Protocol or BGP to exchange routes between on-prem networks to your Azure services. Each ExpressRoute circuit consists of two connections to the Microsoft Enterprise Edge routers, as you can see in the figure here. They have one primary connection and a secondary connection. Microsoft requires that for redundancy purposes. Each circuit can have a fixed bandwidth ranging from 50 Mbps up to 10 gigabytes per second. The bandwidth is shared across all circuit peerings. We are going to talk about circuit peerings in the next slide. Couple of points to be noted here. The ExpressRoute provides two pricing models, metered and unmetered. As the name suggests, metered is where the data outbound transfer is metered, whereas in unmetered there is a fixed cost for your ExpressRoute circuit and the outbound data transfer is not metered. Also, check out a couple of other options available in ExpressRoutes. You can have something known as ExpressRoute Direct, where you don't need to have a service provider or a partner in between, and you can connect directly to the Microsoft's global network. Other option is ExpressRoute Global Reach, where you can link your different ExpressRoute circuits in different regions to make a private network between your on-prem networks. Now, ExpressRoute circuits include two independent peerings, private and Microsoft peering. As the name suggests, private peering is used to connect your on-prem resources with the Azure services. The private peering domain is considered to be a trusted extension of your core network into Microsoft Azure. And it lets you connect your on-prem resources with your cloud resources directly on their private IP addresses. Likewise, for under Microsoft peering, you can connect to Microsoft online services like Office 365. If you have been an ExpressRoute customer and if you have been using ExpressRoute in the past, and the chances are you might have an old ExpressRoute circuit, which might have three different peerings, Azure Public, Azure Private, and Microsoft. Earlier, they were categorized to represent different IP addressing schemes, which Microsoft has now represented in private and Microsoft peering. Now, to understand what a peering is, it is a pair of independent BGP sessions. Each of them is configured redundantly for high availability. There is a 1:n mapping between an ExpressRoute circuit and routing domains. An ExpressRoute circuit can have one or two or both. I mean, it can either have private or Microsoft, or it can have both private and Microsoft peerings enabled for the circuit. Now you can create a connection between your on-prem network and Microsoft Azure in using ExpressRoute in three different ways. Starting with, you can use a co-location, Cloud Exchange co-location, where you can order virtual cross connections to the Microsoft Azure through provider's Ethernet exchange. The provider provides in layer 2 or layer 3 cross connection between your infrastructure to the Microsoft Azure resources. Likewise, you can also use a point-to-point Ethernet link for layer 2 or layer 3 connections over ExpressRoute. Lastly, you can also integrate your WAN with the Microsoft Cloud over ExpressRoute. Now, Microsoft has a global network with ExpressRoute connectivity providers and system integrators. To get the location-wise list, I will suggest you to check out the link that I have listed there. What you see here is a failover scenario for an ExpressRoute, which is used to connect your on-prem resources with Azure resources. In case of an outage, site-to-site VPN gateway is used as a failover connection. If the ExpressRoute is up and running, traffic flows between the on-prem network and the Azure Virtual Network through the ExpressRoute connection through this way. Just in case if there is an outage or there is a loss of connectivity and the ExpressRoute circuit goes down, traffic starts getting routed over the IPsec VPN tunnel through VPN gateway. So please refer the link that I have listed there for the reference architecture on the ExpressRoute with VPN failover. There is another networking service called as Azure Virtual WAN, which brings many networking, security, and routing functionalities together to provide a single operational interface. These functionalities include site-to-site VPN connectivity, point-to-site connectivity, ExpressRoute connectivity. You can connect in multiple clouds through this, and and the important point is you don't really need to use each one of those connectivity features together. You can use a subset of those features depending upon your use case. Now, the virtual WAN architecture is a hub and spoke implementation, which is built in for scaling and performance for your branches users, ExpressRoute circuits, and virtual networks. As you can see in the figure, Azure regions here serves as the hubs that you can choose to connect to, and all the hubs are connected in full mesh to a standard virtual WAN, making it easier for the end users to use the Microsoft backbone for any-to-any connectivity. You can see different virtual networks behaving as spoke networks here, and you have different kinds of connectivity like ExpressRoute, site-to-site VPN, or point-to-site VPN. Moving on, I would also like to touch upon few features which are part of virtual networks, which come in very handy to connect your Azure services privately and securely. To start with, there is a feature called as Service Endpoint, which allows your resources within your virtual network to reach to other Azure services over a private IP address. You just need to enable the service endpoint on a subnet for the particular Azure service that you would like to connect from your virtual network. And there is no additional cost for using a service endpoint with your virtual network. Another service I would like to mention here is private links or private endpoint, which enables access to Azure PaaS services over a private endpoint in your virtual network. The traffic flows on the Microsoft backbone network, and there is no need to expose your services over the public internet. Microsoft has already announced support for private endpoints with most of the services like SQL databases, Azure Storage. For some of the PaaS services, like app services, it is still in public preview, and I believe it's going to go GA pretty soon. The feature is very powerful, and I expect the list to keep growing over the time. It does provide true private connectivity to your resources. Lastly, I also want to mention about a feature known as Virtual Network NAT, or Network Address Translation. Many times there is a requirement to expose a single static IP address on an outbound communication from all the resources running inside a virtual network. For such scenarios, you can use Virtual Network NAT, which once enabled forces all the UDP and TCP traffic to flow from the resources under the subnet to use NAT and show the static public IP address that is assigned at the NAT. Now you can opt for a single static public IP, or you can opt for a public IP prefix when you are configuring your virtual network NAT gateway. You need to set up a NAT gateway, as I said, with a public IP address or public IP prefix and assign it at the subnet level as depicted in the figure. Any questions so far? I don't see any.
Yeah, none so far. We just put another comment out there to remind people to post questions when they have them.
Okay, I'll keep moving. Let's talk about network security groups. You can use network security groups to filter network traffic to and from Azure resources in your virtual networks. It contains security rules through which you can allow or deny inbound or outbound traffic. For each rule, you can specify the source and destination, the port, and the protocol. When you create a network security group, there are some default security rules which gets created automatically, and you can override them with your own security rules with higher priority. You can also have augmented security rules, which allow you to define larger and complex network security rules. For example, you can use something like service tags that represent a group of IP addresses prefix from a given Azure service like Azure App Service or Azure Storage, Azure SQL, and so on. Network security group security rules are evaluated by priority using 5-tuple information: source, source port, destination, destination port, and protocol to allow or deny the traffic. As you can see in the figure, a NSG can be applied at either network interface level or at a subnet level. So this particular NSG is applied at the network interface level. This NSG is applied at the subnet level. And to the left, as I said, there is NSG at NIC level. All the security roles in both the NSGs are executed and given preference depending upon the direction of the communication. For inbound, it first evaluates the rules at the subnet level, and then it evaluates the sub rules at the NSG, which is at the NIC level. For outbound communication, it first evaluates the rule at the NSG2, which is the NSG at NIC level, and then it evaluates the rule at the NSG1, which is NSG at the subnet level. If the traffic is allowed at subnet level but not at the NIC level for inbound traffic, the traffic is denied. Likewise, for outbound communication, if the rules at NIC level are evaluated first and then the rules at the subnet level are evaluated, and if either one of them has denied rule, it will be denied. Likewise, what you see here is for virtual machine 2, there is no no NSG sitting at NIC level. So the only rules that gets evaluated for this virtual machine is NSG1. Likewise, for virtual machine 3, there is a NSG that sits at NIC level, but there is no NSG at subnet level. And for VM4, there is no NSG either at NIC level or at the subnet level. So there are no security rules that apply. The challenges with NSG is that you have to base your network security policies on IP address ranges, which is, I believe, okay in most of the cases, but sometimes it gets tricky to set up the network security policies that align with the application structure. Meaning, if I have to group virtual machines and define network security policies based on those groups, it is not possible, or at least not very straightforward in NSGs. The problem is resolved using something known as the application security groups, which allow us to configure the network security policies as an extension of an application structure. So in this figure, what you are seeing is NIC1 and NIC2. NIC1 is here, NIC2 is here, are members of this application security group called as ASG Web. And NIC3 is a member of application security group called ASG Logic. NIC4 is a member of application security group called ASG DB. Now, none of the network interfaces have an associated network security group. NSG1 is associated on both the subnets here and here, and contain certain rules with the application security group. And within this NSG, we can define rules specific for each of these application security groups, either as the source and destination. The advantage that we get out of these application security group specific rules is that all the NICs that are assigned to the application security group follow those rules. For example, if there is a rule which is assigned to ASG Web, only applies to VM and VM2, and it does not apply to VM3. Whereas if we would have directly applied a rule at NSG1 without an application security group, it would have applied on all the 3 different virtual machines. I hope it makes sense. Moving on, you can also use an Azure Firewall to secure your Azure Virtual Network resources, which is a fully managed cloud-based networking security service. It is a fully stateful firewall as a service that comes with built-in high availability and unrestricted cloud scalability. Like any other firewall, you can define application rules to allow network traffic through your firewall. It comes with some out-of-the-box features like it supports availability zones, it supports forced tunneling, outbound SNAT support, inbound DNAT support. It supports FQDN tags, service tags, and so on. Now, a denial of service attack is a cyber attack in which a malicious party seeks to make a machine or a network resource unavailable to its intended users by temporarily or indefinitely disrupting services of a host connected to the internet, by flooding the targeted machine with superfluous requests in an attempt to overload systems and prevent some or all legitimate requests from being fulfilled. Using Azure DDoS protection, you can protect your Azure resources from distributed denial of service attacks. It comes in 2 different flavors, basic and standard. Basic DDoS protection is free of cost and is already enabled as part of the Azure platform. You can alternatively also opt for standard tier, which comes with additional support options and mitigation capabilities. For most of the use cases, basic DDoS protection is sufficient in my opinion. In the standard tier, policies are applied to public IP addresses associated to resources deployed in virtual networks. You can use Azure Monitor for real-time monitoring for standard DDoS protection. And both the tiers does support IPv4 and IPv6 public IP addresses. I see a question which says, can we specify FQDNs on an NSG when defining source? No, we need to specify IP address ranges. We cannot specify FQDNs. Let me quickly go to Azure portal and show a couple of concepts there. So when we are creating a virtual network, we can enable the firewall at the time of creation, or we can go ahead and create a firewall at a later stage as well. Here is the DDoS protection that I was talking about. We can, by default, basic is enabled. I can go ahead and opt for standard and choose the appropriate protection plan. Here's the peerings that I was talking about earlier. Here is the service endpoints. I can go ahead and add a service endpoint specific for the services that I want to use, like SQL or Service Bus, Key Vault, Active Directory, and Microsoft Web is for app services. Likewise, I can also add, whenever I enable a private endpoint on a particular app service, particular service instance, and attach it to a virtual network, the private endpoint is visible under private endpoints blade. Now let's go to our NSG. So what I did was I did allowed NSG rule on my virtual machine 1 to allow the traffic for ICMP, which is a protocol which is being used for pinging IP addresses. So that's why I was able to ping different virtual machines. For the purpose of this demo, I'm going to change this rule to deny and save it. What this translates it is any inbound ping from any other machine will not work for the virtual machine 1. So right now it's still able to reach because it takes a minute or so before it can propagate the network security rule. Here you go, the network security rule is applied and the request starts getting timing out. I'll go ahead and enable allow the rule. And you will see sooner or later the machine response will start coming up because the NSG rule is allowed now. Here you go. The machine has come back. Now you can also see the rules which are effective together in a combination of inbound and outbound security rules. Under effective rules, I think someone has asked this in the chat as well. So here you go. These are the rules which are effective. Now, if you will see here, I really don't need this particular rule here because all my virtual network traffic is allowed. These three rules that you see here, 65,000, 65,001, and 65,500, these are the three default inbound rules which are added whenever you create an NSG and assign it to a virtual network. And you can, as a best practice, whenever you are creating a rule, you shall create a rule with a higher priority so that that rule can be applied and become effective. The challenge is the last rule that you see here is denied. So it always, NSG always executes these rules based on the priority. So the highest priority one, the lowest priority one will be executed first, meaning the number 300, the rule with the priority 300 is evaluated first, and then so on. And this rule is the last one evaluated. Moving on. Let's talk about routing. When a subnet is created within a virtual network, a default route table is automatically created by Azure with the system default routes already added to the table. Azure system default routes can be overridden with custom routes. You can add additional custom routes as well. All the outbound traffic from a subnet is routed based on the routes in the subnet's route table. When you see what you see here is the list of the default routes that are added in the route table for a subnet. As you can see, each route contains an address prefix and a next hop type. When traffic leaving a subnet is sent to an IP address within the address prefix of a route, the route that contains the prefix is the route Azure uses. Now there are three types of hop types here, ranging from virtual network, internet, and none. For virtual network, the traffic is routed between the IP address ranges within the address spaces of a virtual network. For each address range in the virtual network, there is a separate route created for each address range. We don't need to specify the specific subnet ranges here because the subnet IP address ranges are already covered within the virtual network. For the internet next hop type, the traffic is routed to the internet. The system default route, as seen on the slide, is 0.0.0.0/0. That address prefix can be overridden by adding a custom route. Sorry. All the outbound traffic to internet is routed to the internet through this particular route, except in one scenario when the traffic is bound towards Azure Services. Azure routes the traffic to an Azure service directly on the Azure backbone network rather than sending it over internet, regardless of the region or the virtual network the service is in. Lastly, the traffic routed to none next hop type as expected is dropped. The traffic is not sent to any other location. Azure automatically creates default routes for RFC 1918 IP address prefixes, meaning if you send traffic on private IP address outside your virtual network range, it is automatically dropped. When you extend your virtual network address range to include additional IP addresses, the traffic on these IP addresses is automatically routed to the virtual network next hop type. Now, Azure also offers additional default rules to support different Azure capabilities like virtual network peering and VPN gateways. When you create a virtual network peering between two virtual networks, a route is added for each address range within the address space of each virtual network a peering is created for, with the next hop type as being VNet peering. One or more routes with virtual network gateway is also added as the next hop type here, which is added when we add a virtual network gateway to a virtual network. Likewise, whenever we add a virtual network service endpoint, a route with virtual network service endpoint as the next hop type is added. Now, there are situations where you need to either override Azure system routes or you might have to add additional routes. You can do so by adding custom user-defined routes to the route table. You can create up to 400 user-defined routes inside a route table. You can specify a variety of next hop types in your user-defined routes, like virtual appliance, virtual network gateway, none, virtual network, and internet. As the name suggests, for virtual appliance next hop type, the traffic is routed to the private IP address of a virtual machine hosting a network virtual appliance, or the private IP address of an internal load balancer, which load balances between multiple virtual appliances. For virtual network gateway, as I was mentioned earlier, the traffic is destined for specific address prefixes routed to a virtual network gateway. You shall note here that when we say virtual network gateway hop type here, it only applies for the virtual network gateways which are of the type VPN and not for the virtual network gateways of the type ExpressRoute, because in ExpressRoute you must use BGP for your custom routes. None, as I suggested earlier, it's used when the traffic needs to be dropped. Virtual network is specified when you want to override the default routing within your virtual network. And internet is specified when you want to explicitly route traffic destined to an address prefix to the internet. Now, note that you don't see VNet peering and virtual network service endpoint as the next hop type in the user-defined routes. The reason being the routes with the virtual network peering and virtual network service endpoint hop types are only created by Azure when you configure corresponding resources in Azure. Also, you can exchange BGP routes between your on-prem network gateway and Azure Virtual Network Gateway. It is used with VPN gateways of ExpressRoute type. You must use BGP to advertise your on-prem routes to the Microsoft Edge router. Important to note here is that you cannot create user-defined routes to force traffic to the ExpressRoute Virtual Network Gateway if you deploy a virtual network gateway deployed as type ExpressRoute. You can use user-defined routes for forcing traffic from the ExpressRoute though to a network virtual appliance. When you exchange routes with the Azure using BGP, a separate route is added to the route table of all subnets in a virtual network. For each advertised prefix, the route is added with virtual network gateway as the next hop type. Remember the good old days when we were required to have a jump box virtual machine to connect to other virtual machines in the virtual network? Well, those days are gone. You don't need to have a jump box machine anymore. If you have not heard of, there is a new service called as Azure Bastion service, which is a fully platform managed platform as a service that provides secure and seamless RDP or SSH connectivity to your virtual machines directly in the Azure portal over TLS. When you connect via Azure Bastion, your virtual machines do not need to have a public IP address. And whenever you are provisioning Azure Bastion under a virtual network, you have to create a subnet for Azure Bastion to work. Moving on, Azure does provides many other options to load balance your workloads. Starting with load balancer, which works at layer 4. It distributes the inbound network traffic across a backend pool, which could have plain instances of virtual machines, or it could be made out of a virtual machine scale set. Now, there are two types of load balancers, public and internal. As the name suggests, public load balancer is used for load balancing internet traffic to your virtual machines, and you need to configure a public IP address for front end so that internet traffic can reach to your load balancer. Likewise, internal load balancer is used for load balancing within a virtual network, and it needs a private IP address. For load balancing the network traffic among the different instances in the backend pool, a load balancer uses a 5-tuple hash comprised of source IP address, source port, destination IP address, destination port, and IP protocol number. The hash is used to map traffic to the available servers. The algorithm does provide stickiness only within a transport session, meaning packets that are in the same session are directed to the same server. When the client starts a new session from the same source IP, the source port changes and causes the traffic to go to a different server. To handle that, we can also use something known as source IP affinity distribution mode, which is another way to distribute load from a load balancer, under which we can send all the connections from the same client computer to the same server. It uses a 2 or a 3-tuple hash. If it's 2-tuple, it uses a source IP and destination IP to create a hash. If it's a 3-tuple hash, it uses source IP, destination IP, and the protocol type. For both types of the load balancer, Azure does offers basic SKU and standard SKU that have different functional performance, security, and health tracking capabilities. The point to note is that SKUs are not mutable, meaning once you create a load balancer with a specific SKU, you cannot change the SKU. You need to literally create a new load balancer with the right SKU and migrate the configuration from the old load balancer to the new one. Another service you can use is known as Azure Traffic Manager, which uses DNS to direct client requests to the most appropriate service endpoint based on a traffic routing method and the health of the endpoints. An endpoint is any internet facing service, and it doesn't necessarily need to be hosted within Azure. It could be anywhere on internet. The most important point to understand is that Traffic Manager works at DNS level. It uses DNS to direct clients to specific service endpoints based on the rules of the traffic routing method. Technically, clients just connect to the selected endpoint directly and not through the Traffic Manager. And Traffic Manager is not a proxy or a gateway. Traffic Manager does not see the traffic passing between the client and the service. It just does the DNS routing, and it does uses a few different routing methods that you can opt from, like priority, weighted, performance, geographic, multi-value, and so on. Under priority, as the name suggests, you can route based on the priority that you set for different endpoints. Under weighted, you can distribute either evenly or according to the weights that you define for each of the endpoints. Under performance, you can route your request to the closest endpoints to your users in terms of the lowest network latency. If you use geographic, you can redirect your request to the specific endpoints based on the geographic locations their DNS query originates from. Let me move to the next slide to give a understanding. In this figure on the left side, you see a system with priority routing, where we have defined priorities 1, 2, and 3 for our 3 different endpoints. When primary app goes down, traffic manager picks up the next failover endpoint based on the priority we have defined here, and which is in this particular case is failover A. So the client is then automatically sent to the selected endpoint, but not through the traffic and manager. On the right side, you see where we are using weighted routing, where we have defined weights for different endpoints. Once our primary endpoint goes down, traffic manager identifies the next endpoint with the highest weightage, which is our region B. So the traffic is routed to the region B directly without going through the traffic manager. Recently, there is a service which has been launched, I guess in 2019 it was, which is known as Azure Front Door. It offers layer 7 load balancing capabilities for your application with instant failover. You can think of Azure Front Door as application delivery network as a service. It comes with some of the features like DSA or dynamic site acceleration. It does support TLS or SSL offloading. It comes with web application firewall and DDoS protection. It does support cookie-based session affinity. It does support URI path-based routing, and it does offer free certificates and multiple domain management. Similar to Azure Front Door, there is another offering in Microsoft Azure, which is a layer 7 load balancer, which is known as Application Gateway. It enables you to manage traffic to your web applications. Some of the features it includes SSL offload and SSL policy, similar to Front Door. It also comes with an integrated web application firewall, which is a service that provides centralized protection of your web application from common vulnerabilities like SSL, like SQL injections and so on. WAF is based on rules from OWASP 3.1, 3.0, and 2.2.9 versions. Now, I did touch upon both Front Door and Application Gateway, and I mentioned both of them are layer 7 load balancers, but there is a difference. The primary difference is that Front Door is a global service, whereas Application Gateway is a regional service. While Front Door can load balance between your different scale units or clusters across regions, Application Gateway allows you to load balance between your virtual machines or containers that is within a single scale unit. As I was saying, Azure Application Gateway is a layer 7 load balancer. It does supports URL-based routing as well. Application Gateway can make routing decisions based on additional attributes of an HTTP request, for example, the URI path or host headers. The figure that you are seeing here, in that you can see the traffic is routed based on the incoming URL. If the URL includes images, it routes it to the image server pool. If the URL includes video, it routes it to the appropriate video servers. This is just a snapshot of Azure Web Application Firewall, which I was mentioning in one of the last slides, that it provides a centralized protection of web applications from common vulnerabilities like SQL injection and cross-site scripting. Preventing such attack in application code is technically very challenging, and it might require rigorous effort from development teams. Using a centralized web application firewall does help security management a lot. So this is just a quick snapshot of when should we use each of these services. Uh, Basically, some of the questions we should ask is whether it's a global or regional service, whether do we need to support HTTP traffic or non-HTTP traffic. That way we can choose a service. Otherwise, you can head out to the link that I have posted there down below on that slide, which gives where we have where Microsoft has detailed all the different load balancing options and how we can choose from. In a nutshell, some of the factors that you should consider is the traffic type, as I was saying in the last slide as well. Is it a web application? Is it a public facing or a private application? Do we need to load balance between is it a global uh, service or it's a regional service? What is the service SLA? What is the cost? And so on. Let's talk about Azure Content Delivery Network pretty quick. It's a distributed network of servers that can efficiently deliver web contents to users. CDNs are CDNs store cached content on edge servers in point of presence locations that are close to the end users to minimize latency. What you see here in this figure is that, let's say, a user known as Alice requests a resource from our special CDN domain ending with Azure Edge.net, which runs on a edge server in the point of presence. The the DNS routes to the best performing POP location, which is nearest geographically to the user. If once it reaches the edge server looks for the resource on the server. If it doesn't find, it goes and looks at it sends a request to the origin, which might be a storage account or it could be an app service. Once the origin returns the requested resource, the edge server returns it back to the requested user, and it stores a copy of that on the edge server with a TTL. Likewise, when any other user goes and requests the same resource, if it is still available on the edge server, it returns it back to the user. If not, it goes to the origin and gets it back. Let's talk about network monitoring pretty quickly. There are a couple of services that you can use. The one which I like is Network Watcher, which enables you to monitor and diagnose your health and performance of your network. Using Network Watcher's diagnostic and visualization tools, it helps you to for things like capturing packets on your virtual machines, validating if IP flow is allowed or denied. You can also identify where packets will be routed from a virtual machine and gain insights to all your up network topology as shown on this slide. The other service that you can utilize is known as Network Performance Monitor, which is a cloud-based hybrid network monitoring solution that helps you monitor network performance between various points in your network infrastructure. It does detect network issues like traffic, black holing, routing errors, and so on. It comes with 3 broad capabilities: Performance Monitor, Service Connectivity Monitor, and ExpressRoute Monitor. As each of those suggest, Performance Monitor monitors network connectivity across cloud resources and on-prem resources. Service Connectivity Monitor monitors the connectivity from your users to the services that you care about, and ExpressRoute Monitor monitors end-to-end connectivity and performance between your branch offices and Azure over Azure ExpressRoute. With that, here are some of the resources that I can refer you to for further reading and for your certification preparation. To start with, Azure Architecture Center is a great resource where there are many reference architectures, including a couple of them that are shown you in this presentation. Utilize Microsoft Azure documentation as the source of authority, as it always has the up-to-date documentation. Do follow Azure best practices for network security as listed on that link. And if you have not seen in the past, do check out Microsoft Learn, which is a great resource for free learning. And then Microsoft has also partnered with Pluralsight to offer 200 plus free courses. Do check it out. There are some good networking based courses as well in there. Then do check out Azure Friday, and which is a show on Channel 9, and Azure role-based certifications if you intend to give or appear for a certification. With that, I conclude my presentation, and I would open the floor for any questions that you might have. If not, I would like to thank Jason and Veronica once again for giving me opportunity to speak at this user group meeting. Thank you.
I think there are some questions. If we look in the chat,
is the chat on the Slack or on the Teams meeting?
I see some on Teams. For example, you mentioned network security groups or NSGs for managing a lot of traffic. Curious if in the real world that takes the place of firewalls built into VMs, or is it still common to also use the VM firewalls?
I have primarily used network security groups for majorly the projects that I have worked on, but I have seen customers using using firewall as well. But network security groups does provide good tool available. We can apply it at the NIC level or at the subnet level, which is the primary benefit we get out of using NSGs.
Thank you for that. I'll continue here to read off a couple others. This is Bill.
Okay.
Do you have any thoughts you want to share on Azure cost control?
Azure cost control for networking services.
I guess so. I could give an example to set the stage. I know in my experience, when we look at, say, DDoS protection standard, you could, if you're not paying attention, there could be quite some sticker shock there.
Absolutely.
And I don't know if there are other factors in the networking realm that you want to caution people about, I guess would be the question.
Do check out the VNet peering costs if you are implementing virtual network peering, because how pricing works for Azure networking is by default any data transfer going within Azure is free of cost, and any outbound traffic from any Azure region is chargeable. On top of it, if you are utilizing virtual network peering, it does charges you on the inbound and outbound data transfer from each of those virtual networks. I guess for intra-region virtual network peering, it costs a cent or 2 cents per gig of data transfer. I don't remember on top of my head the exact number, but what happens is when the data leaves virtual network 1 and goes to virtual network 2, eventually you end up paying both at virtual network 1 and virtual network 2. On virtual network 1, it is billed as outbound data transfer, and whereas on virtual network 2, it is billed as virtual network as the inbound data transfer, and that price goes high if you are using global peering as well. So that is another thing that you should consider when you are implementing Azure Virtual Networks.
Thank you for that. And another question is, I'm not sure if you got this one already. Can we specify FQDNs on an NSG when defining source?
I don't think so. I think it's completely based on IP addresses, and we cannot define FQDN. But if I can show you, we can use something known as service tags. So if I go here and go to inbound security rules, there are different options. Any opens up as it indicates, it opens anything over internet. We can specify IP address, an individual IP address or an IP address range. We can specify something known as a service tag, where we can choose from different service tags like internet or Azure Monitor or load balancer or virtual network, so that this is what I was saying, we can these are the aggregated rules that we can define rather than defining the individual IP address ranges. And lastly, I was also mentioning about application security groups. This is how we can specify rules for application security groups, but there's no way we can define FQT and set NSG level.
Thank you. I actually have a question on this. How do you take an application security group and move it to a new subscription?
The last time I have used application security groups was there was no way to create them in Portal. I had to manually create it through PowerShell. And once we create that, they are visible in here, and we can choose the appropriate application security group here and assign it to the rule. Since I don't have an application security group right now, it doesn't shows me any security group here.
Great, thank you. I think we may have gotten all of them except for the ultimate question that comes up at every talk is, are the slides available?
Yeah, I would go ahead and share it with Jason, and we can share it. And I just recall that I think recently they have allowed creating an application security group in the portal as well, which I'm just not showing. So I didn't give it a try before, so probably we don't need to create it through PowerShell anymore.
Cool. Yeah, I'll check that out. Thank you. So, and you said you'd share the slides with Jason. That's fantastic. So I'm going to flip over to Veronica here to, unless anybody has any final questions, you can come off mute and fire away. Is there a good source of repository for PowerShell scripts in managing Azure resources?
I can send a couple of GitHub repositories that Microsoft provides. Go ahead and check out Quick Start templates, where they have, I believe they have it's based on ARM, but I have to go and check it out if they have PowerShell scripts as well. I can send it to Jason, and probably Jason will be able to update it, or I can add it in my slide deck in the resources column, resources page.
Fantastic. Thank you. Looks like that was the last question that I see posted. So I'm going to flip over to Veronica for close us out.
All right, I'll stop sharing my screen.
Thank you so much. It was a great talk, and thanks everyone for attending. I think it was a great event, and if you have any more questions later, you can ask on Slack, and we'll pass them to our presenter, and he'll be able to respond, or we'll somehow find him and definitely will pass your questions to him. I'm sure he'll be happy to answer them later or provide any kind of help. And I have two announcements. One is more global. I just heard that .NET Conf is gonna do a special event on July 30th, so pretty soon. And they're gonna do an event focusing on microservices. So that might be interesting. I think they're planning to do some Azure related, cover some Azure related topics and do some sessions, so it should be fun. And virtual Boston Azure event next month is gonna be on the 16th. So July 16th, Kyle will be talking about bots and share his real life experience working with Azure bot framework and creating bots related to COVID and all the pros, cons, and everything that he learned. I think we'll do it again as a Teams meeting, so same like we had today. So you'll be able to ask questions, unmute yourself. We can turn it to a Q&A session after, so get ready. I just announced the meetup on our meetup pages. So definitely RSVP and join us next time. And if Bill and Jason don't have anything else, I think we are all set for the day. Thanks, everyone.
Thank you.
Thank you.
Thanks, everybody.